on this computer. And it's all yours, sir.
Okay, let me share my screen.
All right.
Okay, great. Great. So George, thank you for inviting me. I know we have a small crowd, but which is okay. We cannot control some of this stuff. So I think stop me if any question, both of you, or if others join, put in the chat, or we can just talk. I think because we are tiny group, so we can, cater it to whatever we need, right? So let's move on. Okay, let me put my phone on. Okay, good. So I'm not going to talk about my bio or anything here, but these are my contact address. So if you have any question, comments after the event, please reach out to me if you have any feedback or something that was not clear. So why should we talk about this, right? Sometimes people think that we move to cloud, everything is rosy, things are nice, right? They have all the redundancy built in the world possible, but why do we need to think about high availability and disaster recovery? So this is a true scenario that happened in one of the region in UK. As you can see, some of the services, and it was actually Azure SQL Database, was down for over 16 hours. Now, the question for us to ask is, can we be down? Can our applications afford to be down for this long time? Some of the businesses we are in or we support as a data professional, I do not think people will be happy with this kind of outage, right? So this is just one example. And I know this one is from 2019, but I have more. If you can go to this URL, and these are, I only just filtered by Azure SQL Database. And as you can see, the recent one was on July 21st of this year. And if you look at the start and end time, just at the top one, right, was close to 10 hours. And then there's another one, the one below is close to 8 hours. So these are some long outage. And then go look at the third line, 11:45 UTC from 12th to 15th, 3 days. Right? So this is the reason that we still have to think about, even though we move to cloud. I'm just trying to make a case that why should we talk about this? Why should people listen to this talk? And then I know most of us are probably familiar with these two terms, RPO, RTO. These are recovery point objective and recovery time objective. And these are not a new term. If you are into this business, I'm sure you probably heard this. But there is a new term that's just floating around for the last couple of years called ERT, which is estimated recovery time. So what is the ERT? They call it's the maximum ERT should be our recovery time objective. And why is that? So if we think about as an application and beyond database, right? So if something happened to a data center, something happened to network, cooling, power, whatnot, it's just not enough to bring up your database and say, we are done, right? There are so many other things, right? If you have express route, your virtual networks, your app servers, your load balancer, a bunch of things, right? The security devices at the edge, all those things needs to be up and running. You have to recover everything. So you don't just look at the database recovery time. You look at each component's recovery time and take the one that will take you longest to recover and publish that as the official RTO for that application. So this is just a visual diagram. What do I mean by RPO, RTO? Just easy to consume. But there's one caveat that I rarely see people talk about. So if you look at this picture, if you see that point, the disaster happened, and then I have something called request for recovery. So what does that mean? Why there is a gap? And sometimes we don't think about this gap, right? So if a server goes down or a major disaster, I think we all know right away, right? It's pretty quick. Everybody get on board, start looking at it, start recovery. But what will happen, say, like at 5 p.m. after business hour, you did a release in the evening, and you did some delete update inadvertently, right? You didn't plan whether your predicate was not right, or you passed the wrong parameter or whatnot. And you might not know that, there's something going wrong. I think you might only find out the next day when, your business is up and running, people are using the application, and they might say something looks wrong, and then you go back and trace it back to the release of last night. So now you can see that there can be a 10, 12-hour gap between the disaster and the request for recovery, right? So, and unless we know that there was something wrong, we're not going to start the recovery, right? So that's why it's also a point that you should discuss when you're talking to your application owners, when you're talking to the system owners, and they're talking to you about the solutions around HADR. So I think this is a point that I think we should mention to them, and we should make it clear that the times we are publishing is actually from the time that we know that something wrong and there is a request for recovery. If there is a gap, that's not calculated in that time, because you never know what that time is. I'm not going to talk much about this slide, and I don't expect you to memorize, but one thing you want to know in Azure, especially the PaaS service, Azure SQL Database Platform as a Service, has many different offerings. And what do I mean by that? So they have different purchase model that you see at the, there is at the top, and then you see different service tier, compute, and hardware type, right? So there's a 4 different tier, how you choose that what what resource you choose to deploy your databases. And this is important. I do not prefer that you first choose this, deploy your database, and then you are thinking about your high availability and disaster recovery solution later on. I think you should think about that first and then walk back and then see what kind of SQL you want to deploy. And the reason is this: when I show you, go further and go to the demo, you will see that there's something called zone redundancy. And I don't know, I know that I didn't talk about this, but if you look at the documentation in the zone redundancy, you can only deploy zone redundancy if you have the Gen 5 hardware. So if you look at this slide, if you say like you decided you want to go to the M series, and then later on you decided to deploy zone redundancy, it's not going to work, right? Because it's not available. That's why you want to first see what's available, what's your RPRTO, talk to the business owner, who is paying the bill, show them what you need, and then walk back and decide, where do you want to deploy. As I mentioned in the previous slide about DTU model versus vCore model, so I'll just touch very lightly on this. DTU stands for Database Transaction Unit. It's actually in this slide. So this is an abstract of your compute, your storage, and your IO resource. So you really not, they don't tell you that you are getting 4 vCPUs if you go with the DTU model. But with the vCore model, you know exactly how many CPU, how much memory you are getting, and what's your guaranteed IOPS. Initially, when Microsoft, came out with Azure SQL Database and the PaaS model, there was only DTU. Later on, the vCore model came, and now if you read the documentation, Microsoft will recommend to deploy in vCore. Does that mean that you cannot go still use DTU, or you have to move everything? No, you do not. I still have Azure SQL databases that are deployed with the DTU model, and I left it like that because it's a little bit cheaper than vCore model, because that's what I need, like that much compute power I need. I don't need more, so I can get by. If I even go to the minimum vCore, I'll be paying more. So you can still have it, but Microsoft's recommendation is to deploy in the in the Vicor model. So now let's get to the topic about redundancy. We'll talk about 5 different redundancy. And the first one, you might be wondering that why I put it there, right? Deployment. So with Azure, with one thing that we see that, things are easy to deploy because we are not, buying computers, we are not buying, servers, we don't need to rack this, we don't need to do network and all that, right? It's all by code. So to give you an example, if you are live in East2 and you just want to rely on the backup, you do not have active replication going to the central or another region, and now something goes wrong, you want to deploy your server, you want to deploy your database, or you want to restore it from your backup. So you want to have a set of scripts, either it's a PowerShell, or whether it's an ARM template, or there is Azure CLI. You want to have a pipeline, or you want to have automation set up that you are deploying it in the same way every time you need, right? That's the beauty of it, right? So you can destroy it in dev, you don't need it, shut it down, destroy it, and you can provision again, you can save money. So you want to have your code also have redundancy set, make sure it's in a source control, make sure it's version, you can get back to your changes and you can look at what you did before. So next is a data center. So in a region, Azure is divided in many regions. Each region have many data centers. It's not just one. Like especially like if you go to a big region, there is multiple data centers. So we need redundancy at a data center level. Now Azure also does one thing. They group a couple of data centers together and they call it a zone. What does that mean? Each zone, and we'll talk more about zone redundancy later on. Each zone has its own power, own cooling, own network. So within the region, you have zone redundancy. Then we are now talking about region redundancy, means if East US2 is down, then I can fail over to Central or to West US. Now, the last point I put geography, and the reason I put it there, if you're in a small country, if you have business, if you're supporting, they might not be as fortunate as us in the US. They might not have multiple regions, right? So they might have to go to a different country. Now, you have to be careful with that, right? Because depending on the business that you are supporting, I can give you an example in my personal experience. At one point, I worked for a company, we had contracts with UK government, some work for them. And UK government had strict rules about data leaving the physical boundary of United Kingdom. So you cannot just replicate that data to Germany or some other place, right? As a region redundancy. So you have to be innovative if you're supporting a business in a country where they don't have multiple region, and you need to come up with a solution for region redundancy. So you might have to do some custom solution there. So I know I said that I'm going to repeat that. So, if you have any question, please, George, stop me, put it in the chat. Juan, you can unmute and let me know. We are just few of us, so we should be able to talk and, get to a discussion if we need to. I don't want to just go through what I prepared. I'd rather, answer any questions or, discuss on any comments that you have. So these are a couple of things that we'll be talking about. Now, again, you might be wondering that why did I put temporal table, right? Is temporal table is a high availability or a disaster recovery solution? Absolutely not. The reason I put it there is if you have it turned on, you can actually recover some of the rows versions from previous point in time. So if you did a deployment, like I said, if you did a delete update by mistake or your predicate was not set correctly, you realize, and then you can go back if you have temporal, if you're using temporal tables. There are some limitations based on the tier that you are using for your Azure SQL database. So I'm not going to go into details, but it's the same as on premises, but look it up. But we're going to talk about other 5 in today's talk. So the first one is the automated backup. Before I go there, I'm going to repeat this theme probably a few times during the talk. Is this chart shows you clearly that if I want to rely just on the backup, my RTO is 12 hours, my RPO is 1 hour. So, but this is a cheaper option, right? You don't have to spend any extra money because some of the backups, come by default with the Azure SQL database, which we'll talk about. But you want to ask the business owner, hey, can you be down for 12 hours? Can you afford to lose 1 hour of data? If this is absolutely fine, that we can recreate this data, these are from flat files, or we have a different source, I'm absolutely fine. This is, not that important, good enough, go with that. But if they say, no, this is not good for us, we cannot be down, show them the auto failover groups. They say, no, we cannot be down for an hour, show them the active geo application, right? So you need to have that discussion. We are not the one to decide which solution to implement. Yes, we are. Once we agree on this, then you show them from the menu that, hey, based on what you told me, I can do this, this, this. This is going to cost this much money. This is going to cost this much money, and then have a discussion. Then, and this is my recommendation as a DB or data engineer. But the RPRTO discussion has to be, decided or have to take place before we implement this. So let's talk about automated backup. Before I give you the numbers about automatic backup, I want to mention one thing is that we lose control of precise RPO. Now, why do I say that? So if you read the Microsoft documentation and look at the yellow, text that I mentioned, on premises, when you set up backup, I can precisely set the date time when I want my full backup, differential backup, transactional backup. In Azure, I cannot. I do not control this. Microsoft controls this based on my workload. But there are some parameters. But if you look at this, the full happens on a weekly, differential happens in every 12 to 24 hours, transaction log every 5 to 10 minutes. So, as on premises, I could say, take my transaction log backup exactly at this minute and then exactly at this frequent interval. I lose that exact control. That's why I said that we lose control on the precise RPO, right? So just keep that in mind. As soon as you deploy Azure SQL Database, you do get point-in-time backup. It happens automatically. You do not have to do anything. And the retention is 7 days, except basic tier. You can slide it up to 35 days, but not beyond 35 days. And we'll see this during the demo. Now, some of us are in the business that 35 days is not enough. Like I work for a company that does investment management. 35 days is not enough for us. We have to save some of the data for a lot longer because the Federal Trade Commission, FTC, can come and want to look at a trade, want to look at a bunch of things. So 35 days is not enough for us. So for people like, if you have a business like where I work, you can take advantage of the automatic long-term retention, where you can save up to 10 years. And once you set it up, you forget about it. Microsoft does it for you. You can have retention up to 10 years, but you can control it. You can set it up what you want. And then by default, these backups get replicated to a different region. Again, now if you have a business that cannot your data cross the boundary of a physical area, make sure you turn that off, right? You don't want to get into any legal trouble. But by default, it will get copied. So if my East-US2 is down, I mentioned East-US2 because it's closest to me. I'm in Boston. East-US2 is near Ashburn, probably more closer to you folks. So the recommended pair is a central US, so they get continuously copied. So if East-US2 is down, you can always bring up a logical server in another region and you can restore from those backup. This is a chart, you don't need to read the whole thing, but what it's saying is that how can I design my long-term retention? You can say my weekly backups keep for this many years, my monthly backup and keep and for this many years, and my yearly backup. So what's a yearly backup for a database? So here for a yearly backup, you have to say that, like for this example, if you look at the top row, it says that my 3rd week of the year's backup is my yearly backup. So keep that for 5 years. If you look at the bottom line, it's saying my 16th week of backup, keep it for 10 years. I get this question all the time. What can I do with these backups, right? So, I put some pointers here. We can restore from point-in-time backup if you need to recover to a point. If you delete your database, you can always restore from point-in-time. You can restore with a different name. You can restore to a different region. You can also restore from a long-term retention, a long-term backup. One thing you want to be careful, if you delete your database, you still have access to your point-in-time backup. If you delete the logical server, your point-in-time backups get deleted. You only have access to your long-term retention. So be careful with that. This is another question I get a lot. Microsoft documentation, as per Microsoft documentation, they do test restore, they do DBC check DB, they do checksum. This is strictly talking about platform as a service, has Azure SQL Database. This doesn't happen for every flavor. Like for example, DBCC check DB, Microsoft doesn't do it automatically for managed instance. You have to schedule that by yourself. All backups are taken with checksum. That's documented in the Microsoft documentation. Another question I get, can I restore on premises? No, you cannot. You cannot take those backups and restore in a traditional way. But you can use some of these tools that I mentioned here to extract schema and extract data. There's something called backpack, and you can try to restore in on-premises SQL Server, or you can reconstruct. I would say not restore would be the wrong word. You can try to reconstruct the database in on-premises. Any question?
I was going to ask the you talked about if you destroy your SQL Server, you lose your point in time. So that point in time is the time from the point of delete back to the last full backup.
No, you lose all your point in time backup. So with Microsoft, as soon as you delete Azure SQL Database, they delete all the backups that was taken as part of point in time. They delete all the backups. You only have access to your long-term retention backups. So if you haven't set up long-term retention, you delete your database. Sorry, I take that back. If you delete your logical server, it deletes all the point-in-time backup for the databases that was in that server. If you only delete your database, your point-in-time backups are still available for you up to that time, whatever the retention period is. So when you are deleting a logical server, just keep that in mind, that I won't be able to restore these databases from the point in time. That my only available is the long-term retention backup. Did I answer your question or no?
Yeah, I think so. So I guess the question is, at what point does a backup become long-term retention?
Oh, you have to set that up. So when you go to the demo, these are two separate things.
Okay.
Yeah, they're two different storage. They're two different things. I mean, they get, they literally copy it from point in time,
Yep.
but they put it in a different storage, which get replicated to another region.
Gotcha.
So, and I'll show you that when I go to demo. And if it is not clear at that point, please ask me again. Don't hesitate. So let's move on and talk about built-in HADR. And I'll show most of this. I'll show you in the demo. I'll try to finish talking in probably next 10 minutes. I want to put more time in the demo because all the info I'm showing you here is from Microsoft documentation. So when you deploy Azure SQL Database, without you doing anything, there is some built-in redundancy. What do I mean by that? So if you remember that slide that I showed you that has different TRSQ, purchase model and all that, there's something called basic, standard, general purpose tier. So when you deploy Azure SQL Database in this 3 tier, if you look at this picture on the right, this is what happened. We get one server with attached SSD, which has our TempDB and some configuration data, but our data and log file actually sitting in somewhere else, right? If you look at the picture. And if something goes wrong, then what Microsoft does, and there's something called Azure Service Fabric, which is continuously monitoring this. If it sees an issue with that compute, with that VM or that host, what it will do, it will detach our data and log file. It will find another host which has a spare capacity. It will start a SQL Server.exe. Then you get a fresh TempDB. then it will attach our data and log files and put us back into business. And you do not have to do anything. You do not have to change your connection string. Yes, you're going to get timeout, but if you keep retrying, it will automatically get connected. And we'll see this during the demo. In general purpose, standard and basic, it takes a little bit longer because it has to detach and attach the log files. Also, the recovery will depend on the spare capacity. It has to find a spare capacity first, but Microsoft generally keep a spare compute capacity so it can fail over when it needs to. If you look at the bottom, your data and log file is not geo-redundant. It's only locally redundant, means within the data center. Your backup files are actually geographically redundant. It's going to a geo-redundant, it's going to a different region also. Also, it's zone redundancy, which we'll talk about later on. Now, if we go to premium and business critical, you see the difference here. Your data and log file is attached to the compute and in SSD, and you have 4 copies of data and log file. So now if the service fabric find a problem with the compute, with the primary replica in the picture, it will fail you over to the secondary. But here it doesn't have to detach and attach your log file, so it's a lot quicker. Plus, you can use the secondaries for your read-only traffic. At least one of the secondary is always in sync with the primary, and that's the one who will pick up the role of the primary in case if something happens to the primary replica. Backups are same, continuously getting replicated to a different region. For connectivity, you do not have to do anything. So your app servers, continuously making a call, it will see a connection timeout, keep trying, and it will automatically connect. And I'll demo this during the demo. And this is without doing anything. These are all built in. We are not paying anything extra. As soon as we deploy, we get this by default. So now we talked about redundancy in the data center. Next is a zone redundancy. And what's a zone? I talked about this briefly before. So it's a bundle of multiple data centers, one or more data center. And anytime Microsoft has zone in a region, it should have at least 3, minimum 3. And as you can see here, your network, your power, your fiber connection, they all are independent. So how does Microsoft do that? Pretty much same concept what we saw before. But here, what it does, it segments the data center into zone. And your data and log file, if we go here, it only said locally redundant. As soon as you turn on zone redundancy, it will be zone redundant. So it will make copies to other zones too. And this is disabled by default. And in general purpose, if you turn it on, it's going to cost you extra money. And it's only available in Gen 5 compute. That is one of the reasons I said at the beginning, first you decide what kind of solution you want, then walk back and choose what tier you want to deploy your stuff, your databases. So again, same thing. If something goes wrong, it will find spare capacity, detach data log file, start a SQL Server exe, attach data log file, and you're back into business. If you're in premium and business critical, it's different. You get minimum 4 copies, total 4 copies. Your data and log file is attached. So you just have to find the spare capacity. And you don't have to find, sorry, these are already reserved. You just have to fail you over to a different host in a different zone. Here, if you turn this on again, it's disabled by default. And the reason it's disabled by default because as soon as you turn it on, you are moving from asynchronous replication to synchronous. And that can increase some of the latency from your application calls. So you first definitely want to test it, that if that increase in the latency or increase in that response time is acceptable for your users before you turn this on. In business and premium and business tier does not cost you any additional money, but you still have to turn it on manually, and it's only available in Gen 5 because you're already paying more money, so they don't charge you any extra for that. Again, this is another document. Like I said, I'll remind you a few times. This is a link to a Microsoft documentation. It gives very detailed breakdown by percentage of the SLAs. What is the SLA, how it differs with zone on, zone off, and all that. So make sure you consult this, take it to your partners, sit down with them, talk about it. So we talked about data center, we talked about zone within a region. Now we are moving into region redundancy, right? What happened if the whole central US, like the storm, we are facing right now, right? In such a situation, what will happen if the whole region goes down, right? Or not available. And if your business needs to be up 24/7, you need to do some preparation for that. So that's where this active geo replication is coming. And active geo replication is actually the same code base what we know on premises. We call always an availability group, right? It's the same concept. So the first one is active geo replication is actually per database. It's not per server. It's not a group of database. It's a single database. As you can see in this picture, so we have a logical server in the primary, logical server in the secondary. The databases are continuously getting replicated. And it's the asynchronous replication. But one thing is guaranteed here, that you do not get partial transaction, right? So for a single transaction, everything either makes it to the secondary or nothing makes to the secondary. That's guaranteed. Secondaries can be used for read-only traffic, and up to 4 secondaries you get. And again, one thing here is that you have to manage the connection string in case of a failover. In this case, Microsoft isn't going to do it for you. So this is different than what we have been talking about auto redirect. We don't have to do anything. It will automatically reconnect here. This is not going to happen. You have to do it by yourself, or someone has to do it. If you have a transaction that is so important for your business that you want to be 100% sure that it makes to the secondary, and you cannot afford to lose this in case if something goes down in between. Look at this store procedure in the books online. You can embed this in your transaction, but use it wisely, right? Because if your active geo replication is geographically dispersed very far, you will probably wait longer for the acknowledgement back. And if you are using this, in too many places, your application might slow down. So you have to use it wisely, or ask your developers to use it wisely. Now, historically, when Microsoft came out with Azure SQL Database, the idea was a single application will be supported by a single database. But as we know, oftentimes that's not the case. We need a bunch of databases to support application. So now when it comes to failover on premises, as we know, we have always an availability groups that we can fail over. A group means all the databases will be failed over at the same time. They're transitionally consistent. So Azure didn't have it before. And this was asked by people that we need to fail over multiple databases, which is transitionally consistent. Then Microsoft came out with auto failover groups, and two major difference here. You see compared to Active Geo-Replication. Here you see two databases, means we can do one or more databases, group them together, and you can fail them over together. Also, you see something here called read-write listener and read-only listener, which we did not see when you're looking at the Active Geo-Replication. So what does that mean? Here you get a listener name that if you use the listener names in your connection string, when you fail over or fail back, you do not have to touch your connection string. You do not have to change anything. It will automatically redirect you to the right place. This is what I'm talking about the listeners, right? So instead of a server name, you're going to use this failover group name .database.windows.net, and if it's a read write, if it's a read-only connection, then you put the secondary in between. When you set up this auto failover groups, there is something called grace period with data loss hours. I will highly urge you to look at this setting because this is important. This dictates if you want an auto failover or you want to control the failover by yourself if there is a disaster, right? So if you're a small company, 9 to 5, nobody's watching this stuff after 5 o'clock, maybe you want to take advantage of it. If you're a place 24/7, you have operations center or whatever you call that, you might not want that. You might want to have more control by yourself. So look at that, read about it. It took me a little bit of effort to understand this 100%. I had also, there was some wrong definition or some confusing definition, I would say, in the Microsoft documentation. So I worked with a couple of program managers like Dimitri Furman to fix some of those languages there. Yeah. So I'm not going to read this. I created this for easy consumption. What are the differences between geo-replication and auto failover groups? Which one I should deploy? Which one I should choose? What I need to know. So this chart will help you to decide between the two. I get this question often, how can I check my replication status? So this is just a copy paste from books online. You can use this. This is a checklist, and I'm not at all saying that this is an exhaustive checklist, but I put some pointers. If you're new to this business, I think these questions or these pointers can help you to start a conversation with the application owners, with the system owners about your RPO RTO. So this will give you some pointers. And if you think, if you can think of anything else that I should add in here, send it to me. I'm not claiming that this is the full list, but I think some of the questions, when you start asking, it will lead you to other questions, answers, and I think at the end you can have a positive discussion and agree to RPO RTO, and then translate that to one of the solutions that I showed you tonight. So that's pretty much on the slide. So I'm going to go to demo, and probably this will be a good time if any questions, comments, anything you want to talk about before we go to the demo.
Juan, please feel free to unmute yourself if you got a question.
No question. Thank you.
Okay, thanks. I'll move on then. So what you're seeing on the screen is a tool called Azure Data Studio. And I'm using a PowerShell notebook. Azure Data Studio is a lightweight tool written by Microsoft. It's multi-platform, it's extension-based. What do I mean by that? It's very lightweight. You can enable and disable extensions that are written by Microsoft, some other companies, individuals to add more functionalities. You can add it, use it, and you can disable it. So that's how you can customize it. Notebook is something, it has different kernels. I'm using PowerShell, but you can have other languages. It lets you write your comments, URLs, pictures, your code, and save the result and send it to someone. And you can, you don't have to do the stuff that I'll be doing tonight. I can do everything in the portal, but I choose to use PowerShell just so I can share it with you, and you can read my comments, you can follow along and all that. Plus, I can reuse it, right? But this is not the only way to do it. There are many other ways you can do it. So I actually ran up to here before the meeting started because of the interest of time. So demo starts here. So what is at the top, right? So you might be wondering, am I hiding something or what's going on there, right? So I will bring this to show you. So what did I deploy so far? So I have a resource group. It's a logical container. It's good to use a resource group because once I'm done with the demo, I can just delete the resource group. It will delete all my resources. I have 3 logical SQL server and I have 2 databases. That's all I deployed. I did not set up any Active Geo application. I did not set up any auto failover group. I haven't done anything. I just deployed this and just so you can save some time. So the first one we'll be looking at is a backup policy, right? And George, I know you had a question, so this might answer this. So if you go to a server, go to backup, and this is a database we have. Go to the retention policy and say, I told you that by default, we get point in time retention for 7 days. And we have no long-term retention. And as I said, I can bump this up to 35 days. I can also set up my long-term retention from here. But as I said, I'm not going to do anything from the GUI. I prefer to do it here so you can, do the same later on. So as you can see here.
A quick question for you though.
Yeah.
Back on the demo page there on the Azure, when you were highlighting the options, you were where you could change your configuration. Over here where it says weekly LTR backups, it has weeks as a drop down. What are your options for the weeks part?
I can even go to year.
Oh, you can go to days even. Okay.
I can go up to 10 years max.
10 years max, but you can also have it go to long-term backup every day as well.
No, I cannot do it. This is a weekly backup. I can only say how many days to keep. So I can put this.
Oh, okay. So it's still
But-
only weekly and long-term.
Yep,
Okay.
weekly. Your granularity is weekly, not daily.
Okay.
Here you get daily up to 35 days.
Gotcha.
Okay.
Thank you. Thank you.
Good question. No, this good question. I like it. That's why I want to, show it over there. And then, so now we're going to set up a weekly retention of 12 week, yearly 5, week of the year is 16, right? And we could have done it over there. But as I said, I'm going to have some scripts to share with people. Plus it's repeatable and I know it works. So now if we go there, cancel this. If we refresh, you see here now, weekly 12 weeks, 5 years. The 16th week's backup is going to keep for 5 years. I do not have any monthly retention. And then if I want to check this out, we can now see that, it's populated. And if I remove the long-term retention for some reason, right, I just put this command so you have it handy. You can remove it. So the next one is a built-in HADR, right? Even a couple of years ago, Microsoft actually did not had this command. So this command is actually not for failover. it's not for us to fail over. This is for test purpose. I think even today, if you fail over using this command, they won't let you to do it for another 15 minutes because, in their data center, people can cause, moving stuff for nothing. They don't like that. This is just for test purpose. But this was not there before. Before, you just had to trust Microsoft that, there's built-in HADR solutions, right? There's built-in redundancy. So I have example for a general purpose. I also have an example for critical tier, business critical tier, right? Because if you go here, hold on, let me close some of these windows. This is bothering me because, okay. So if we go here, as you can see here, I have two databases. They're in two different SKU. One is in business critical, one is in general purpose. So I'm using a tool called OSTress. If you do not know what's the OSTress, I put a URL here. This is very useful. It's written by Microsoft. You can synthetically generate some workload on your server if you're testing, right? So what I'm doing here, I'm using this. I'm just going to be doing some select count from the customer table, just to pretend that this is our app servers and it's running. So let me run this and then explain. So just pretend like this is our app server. It's working fine, right? It's doing the reads. Now, if the service fabric see there's some issue with the compute, with the VM network, whatever, right? And it initiated a failover. So that's what we just did. We said, something wrong. Now we see that error message, right? Cannot connect, and we are back. So see how quick automatically moved us to a different host. And here I collected some timings. It took about 16 seconds, but 16 seconds is to my terminal, right? But as you saw, the failover happened a lot quicker. Get acknowledgement back. I'm in Boston. It's about 600 miles and all that. And plus, it's a home network. Not like your express route or anything. So it's pretty neat. Any question here? Was that clear what I was trying to show you? Okay. So we saw the auto failover. Now let's talk about active geo replication. And if you remember, I said active geo replication is at a database level, right? So if we go here and we go to the replicas, we can see that we do not have any replica. Means this database is not getting replicated to a different region, right? We haven't set up anything. So what I'm going to do now, this is my server. The database is sitting here. And I have another server with no database. So I'm going to set up replication between these two for that single database, for this database. First, we get this, populate this variable, and now we issue the command new Azure SQL Database secondary. And if we go to the portal now, you can see here now it was empty, right? Primary here, East US, secondary is in West US. Still working, still sitting. Because the database was not there, so it's going to take some time, to seed and bring it ready for read. Once you set this up, you can also redirect your read-only traffic to the secondary. That's the advantage. You do not have to pay anything extra for that. So once that is done, I'll also show you how to fail over, and then we'll fail back. So it should be done now in the portal also, because it shows. Yep. So now it's readable, right? So as you can see, we have this. And if we do a failover now, so just keep that in mind. We have East US is our primary, West US is our secondary, right? So let's initiate a failover. You see already the primary is in West US and the replica is in East US. So it reverses the role. And I'm just going to fail it back for the next demo. So the next is auto failover group we talked about, right? So we'll bundle this databases into an auto failover group. We get aliases that we can use. Now, if you remember, I said active geo-replication is at a database level, but failover group, you can have multiple database, right? So if you go to a database pane, you do not see anything called failover group. In order for that, you have to go to the server pane. And now you'll see the failover group. And we do not have one right now. So what we'll do, we'll create a failover group. At this point, we are just creating a group, but we are not adding any database. It's an empty failover group. But you have to give, the server name, the secondary server name, and a failover group name and all that. Yep, so we can see that we have a failover group name. These are the servers. That's the setting that I was talking about, the grace period. But we do not have any database count. So if we click this, there's no database here. And if we go to the edit configuration, that was the setting that I was talking about, automatic failover. It's the minimum is an hour, and it can go up to 24 hours. I just have this for 2 hours. I can have it also manual, right? If I want to control it. Now let's add a database. We're going to add a database to the failover group. It's the same database that we had before. This will be quick because it's already in sync. You see now there's a database count. And you can see here, it's getting replicated, right? If we go to database, we have a database name. And these are the two endpoints that I was talking about. So you can copy this, put it in your connection string, and then you do not have to worry about where is your primary, where is your secondary or read-only traffic. It will automatically route you to the right place. And we're going to initiate a failover. We can also do it from here, failover, forced failover. If you do a planned failover, it will sync first, then it will do the failover. Forced is like, don't worry about it, just failover. You can lose data. We can see the primary is in East US, secondary is in West, right? And we should see the role change. I wish there was a refresh button. There is not. I don't know why. There should have a refresh button on this page. Oh. Okay. Yeah. So the primary is right now in West US, secondary is in East US, right? So the failover did occur. And if you just want to see the status of a failover group, what are the databases member of that, what's your grace period, you can always run this command. And it doesn't do anything, just give you a bunch of information. Where is your, which region you are doing, resource group name, and all the details of a auto failover group. So I'm not going to show this one, but I put it there because I talked a few times that you get your secondaries, you can use those as a read-only replica without costing you any extra money. So, this is a test that you can do and prove that, yes, if you have a connection strings that is like application intent equals read-only, it will actually redirect you to a host that's only set for read-only, and you cannot write to that. So you can prove that. So that's pretty much I had for demo. I'm going to go back to the slides. So these are a bunch of resources because, I know I showed you multiple solutions, a couple of, different ways to do things. So if you want to read more, understand more, these are some of the URLs that I put in. And then I also have this stuff in GitHub. I'll probably refresh the repo one more time. You can download, use it, share it. I really don't mind. And then, these are my contacts again. And then I want to thank you again. Thank you, George and Juan, for coming in and listening to me. So I will stop sharing. No, let's keep the share on. So yeah, so any questions, any comments, or anything I can answer for you?
Well, thank you very much. I really appreciate that. I'm going to stop the recording.